Now let us look at the example of recursive function. I have a recursive function here, that is function fun, which is taking parameter n, and a recursive function is one which calls itself. So this is calling itself. So a function calling itself is called as recursion. Now this is having value n, but it is calling with n minus 1. So it is modifying the value so that at one time it becomes less than or equal to 0, so that function can stop calling itself. So every recursive function must have some condition so that it terminates after some calls. Now from the main function, I am passing 5 to this function fun. Let us see what will be the output. So it is printing 5, 4, 3, 2, 1. So let us see how it is working. So for that, I'll put a breakpoint here and I will run the program. See here in the watch, the value of n, you can see it is 5. Then it has entered in 5 is greater than 0. Yes, it will print this one now. It will come inside and print. So if I continue execution, then it will print 5. Then it will call itself again. Now again a new call. So what is the value of n now? That was 5. Now it became what? 4. Now it became 4. Yes, it has become 4. Now if I continue execution, then let us see what happens. 4 is greater than 0, so it will print 4. Then it will call itself again, and now this time the value of n will be 3 because 4 minus 1 is a 3. Now the new call, there's a new function call with the value of n as a 3, and 3 is greater than 0, so it should print 3 and call itself again with 3 minus 1, that is 2. So let us continue execution, print 3 and call itself with 2. Now the value of n has become 2, right? 2. So it is calling, right? So now it will be 2 minus 1, so it's going to be 1 if I continue execution. Continue, print 2 and call itself again. Now the value of n became 1. Yes, 1. 1 is still greater than 0, so it's going to print 1. Then it will call itself again with 1 minus 1, that is 0. So I'll continue execution. It has printed 1. Then it has called itself again with n value as 0. Now n is 0, 0 is not greater than 0, so 0 will not be printed and it will not call itself again because this is inside the condition. Because the condition is false, so it will not enter inside, so it will not call again. This call will not be done. So let me continue execution. Yeah, it has came to the end of a function. Now watch carefully. If I print execute again it is coming back to the end of a function, again coming back. See, it has called itself total 6 times. 5, 4, 3, 2, 1 and 0. So it has called 6 times, so 6 times it has to end the function, ending the function, ending the function. Next, now it has came back to the main function. So that's it. I'll stop this. So this is how recursion works. Now let me make some change in this function and show you the execution. Now let us write this print after the call. Now let us see what is the output. I'll remove the breakpoint and I'll show you what is the output of this function. So only the difference is that I have written cout after the call. So the output is 1, 2, 3, 4, 5. So it is printed in the same order. So how this is working? I'll put a breakpoint on if and I will run. Now see the value of n, that is 5. So it will enter inside, condition is true. So it will first line inside if. See, this is the first line inside if. So it is calling itself again. So it will call again itself with value 4. So now again it has came from here inside and the value of n is 4. Right, value of n is 4. Then 4 is also greater than 0, so 4 is greater than 0, so it will enter inside and the first line is 4 minus 1, so again it will call itself. So I will just make the calls. Now the n value is a 3, now n value is 2, now the n value is 1. Now see, this n value is 1. So 1 minus 1, 0, it is going to make a call again with the value is 0. Now again it is 0. So 0 means it is not greater than 0, so it will not enter inside if and it will not call the function. it will not call the function again, and it will not print the value of n as 0. It will come out. Now let me continue. It will come out. Yes, you can see that it has reached the end of the function. Now, if I continue, you remember it was calling itself every time, but it has not yet printed. So it will go back to the previous call and start printing. So it will go back to this call, right? Where you can see the value of n is what? 1. Oh, just now it was 0. So it is in the previous call. Previous call it was 1. And print 1. That's it. It will go back to the previous call. So previous to this one it was 2. Now you can see that the value of n is 2. Value of n is 2. Yes, it is going to print a 2. It will print 2. Then go back to the previous call where the value of n was 3. Now the value of n is 3. So it will be printing 3. Yes. Let me continue. So it will print 3. Yes. Again it will go back. See, it's at the end of the function. It will go back now, right? It's at the end of a function. So it will go back to the previous call where the value of n was 4. So it will be printing 4. Then again, previous call where the value of n was 5. So it will print 5. That was the first call. So it has returned till the first call and now back to the main function. And that's all. This is how recursive functions work. And recursive functions are more similar to loop, but these are more powerful than loop. So at some places where the loops are not useful, we use recursion. And sometimes we can use either recursion or we can use loop. So recursion is better than writing loops. But it's difficult for understanding its working. So once you spend some time on recursion and learn how to write them, then definitely that looks a lot easier than writing loops. So that's all about recursion.